Hello student. In the first chapter, in the first lecture, we studied the different ways of expressing the concentration of the solution. In that, we learned mass percentage to define the concentration of the solution, mole fraction, molality, molarity, and normality. That we have, I said we will discuss this in other lecture. Now we will try to learn how we can solve the numericals based on this problem. So I am discussing here some basic numericals which will help you to solve all other numericals, and these numericals are the foundation, or the you can say the base of the solving other numericals based on this concentration problems. So the first numerical is a sample of NaNO3 sodium nitrate weighing 0.38 gram is placed in a 50.0 milliliter volumetric flask. The flask is then filled with water up to the mark on the neck. So what is the molarity of the solution? So in this numerical, we have to calculate the molarity of a solution that has NaNO3 whose weight is 0.38 gram and the volume of the solvent is 50.0 ml. So how we can solve this problem? Molarity. The formula of molarity, as we discussed in previous lecture, molarity is equal to weight of the solute in grams upon molar mass of the solute into volume in liter. So how to calculate the molar mass? This we have learnt in class 9, but I will repeat it once again. So molarity, molar mass, MOLAR, molar mass, that will equal to NaNO3. The atomic weight of sodium is 23. The atomic weight of nitrogen is 14. And atomic weight of oxygen is 16. And we have 3 atoms of oxygen. So we will be multiplied by 3. And we will be getting 85 gram mole inverse. On adding, we will getting the value 85 gram mole inverse. So now we will solve the problem. Mass of the solute in gram, that is dissolved, is equal to 0.38 gram. M is the molar mass, that is expressed in gram mole inverse. This is the unit, gram mole inverse of solute, that will equal to 23 plus 14 that I already discussed 85 gram mole inverse. Now V is the volume liter of the solution, that will equal to 50 milliliter. This, since molarity is expressed in liter, so we will be converting this value into liter. So 50 ml, this is in milliliter. When we multiply it by 10 raised to minus 3 or divide it by 1000, it will get converted into liter. So the value will become 0.05 liter. 0.0. Now we will put these values in the formula. Molarity will be equal to 0.38 gram upon 85 into 0.05, and we will getting the answer 0.089 mole liter inverse. This is the unit. You can see the definition of molarity is weight of the solute dissolved in per liter of the solution. So you can see the unit is mole liter inverse, moles of solute dissolved in liter of the solution. You can see the value, right? So this is how you can solve the problems based upon molarity. First you have to calculate the molar mass of the solute, then you have to calculate put these values in the formula, and you will be getting the answer. Now we will be proceeding towards some more difficult problems, but before that we will see a question numerical in which we will be having all the terms by which concentration is defined. You can see in example number 2. This is example number 2. You can see on the screen example number 2, that is 500 centimeter cube. This is the way, one more way of expressing the volume. Since cube is the, you have learnt in maths, cube is the unit of volume. So 500 centimeter cube aqueous solution contains 8.0 gram of an acid. We don't know which acid is it, but its molar mass is given, that is 80 gram mole inverse. The molar mass of the acid is 80 gram mole inverse, and the density of the solution is 0.99 gram centimeter cube inverse. This is the way of expressing density, that is mass upon volume. Density is equal to mass upon volume, that you have learnt in math. So 0.99 gram centimeter cube inverse. Now the problem is calculate mass percentage, strength, molarity, molality, and mole fraction of the acid. So we will solve it one by one. First of all, what values are given? We have been given mass of solute is equal to 8.0 gram. You can see 8.0 gram, and volume of the solution is 500 centimeter cube. That is directly converted into 500 ml. Now density of the solution will be equal to 0.99 gram centimeter cube. Now first, mass percent of acid. We will put this value directly into the formula. Weight of the acid, mass percentage is calculated by weight of the acid upon weight of the solution into 100. So first of all, you will calculate the mass of the solution. Mass of the solution will be equal to, or weight of the solution will be equal to volume into density. Density is equal to mass upon volume. So mass of the solution will be equal to volume into density. That will be 500 into 0.99. 500 volume and 0.99 is the density. We will be getting the mass of the solution, that is 495 gram. Now we will put this in the formula. 8.0 gram into 100 upon 495. 8 is the weight of the solution, that is given, and weight of the acid, that is given 8.0 gram, and weight of the solution we have calculated 495 gram. So this will be 8.0 gram into 100 upon 495. The answer is 1.62 percentage. Alright, so we have calculated the mass percent of the acid. Now the next question is calculate the strength of the solution. We have to calculate the strength of the solution. So you can see strength of the solution will be equal to 1 liter will be equal to 1000 ml, that will equal to 1000 centimeter cube, right? Now strength is equal to mass of the solute. Strength is mass of the solute in 1000 centimeter cube volume of the solution. Means always we are defining the strength in 1 liter or 1000 centimeter cube. So 8.0, here the volume of the solution is 500, but we are defining it in 1000. So we are expressing this value in 1000. That's why we are multiplying this value by 1000. Now 8.0 into 1000 upon 500. Since you might get confused why we are multiplying this value by 1000, this is because we are expressing this in 1 liter. We are expressing strength in always in 1 liter, but here the volume is 500, so we are expressing this in 1 liter, so we will multiply it by 1000 centimeter cube. Now 8.0 into 1000 centimeter cube liter inverse upon 500 centimeter cube. Centimeter cube will get cancelled, and we will be getting 16.0 gram liter inverse. 16.0 gram liter inverse, right? So this is the strength of the solution. We have got the strength of the solution. Now next, to calculate the molarity, you can see molarity is equal to weight of the solute upon molar mass of the solute into volume. So weight of the solute is given 8.0 gram and mass of the solute is also given, that is 80, and the volume is 500. So we are converting this in the liter of the solution, so multiplying it by 1000. So we are getting the value 0.2 mole liter inverse, right? We are getting the value 0.2 mole liter inverse, right? This is the way to calculate the molarity that we have discussed earlier. Directly we are putting the values in the formula. Weight of the solute 8.0 upon 80 into 500 multiplied by 100, we are getting the value 0.2. This is easy way to calculate the molarity, but students get confused in case of molality. In molality, we are not expressing the concentration in terms of liter of the solution. We are expressing it in mass of the solvent. Mass of the solvent. So we have to calculate the mass of the, first we have to calculate the mass of the solvent. You can see mass of the solution is equal to 495 gram. 495 gram. Mass of the solution is 495 gram, and mass of the solute is equal to 8 gram. Mass of the solute is equal to, you can see mass of the solution. Previously we have calculated mass of the solution is 495 gram. Now mass of the solute is 8 gram, that is given in the question. So simple mathematics, mass of the solute is equal to mass of the solution minus mass of the solute, that will be 487 grams. So we got the mass of the solute. Now we will put this in the back into the formula. Weight of the solute, that is given 8.0 gram. Mass of the solute, molar mass of the solute, that is 80 gram. Into weight of the solvent, we calculated 487 gram into 1000, and we are getting the answer 0.205 mole kilogram inverse. So it is quite simple, but we have to keep focus and in this point that in molality you have to calculate the mass of the solvent. We are not getting we are not putting the value in liter. You have to calculate the mass of the solvent. And one thing more, you can see here molarity is expressed mole liter inverse. You can see here the unit is mole liter inverse, and here the unit is mole kilogram inverse. So always remember, molality is mole per kilogram of the solvent and molarity is mole per liter of the solution, right? So keep these 2 points in your mind, and you can see here now we will calculate the mole fraction of this calculation of mole fraction is very important from 12th point of view, because in 12th you will be getting questions on mole fraction in solution chapter. You can see how to calculate the mole fraction. Initially in this question, acid is dissolved in water. So acid is the solute and water is the solvent. So first we will calculate the moles of the acid. So moles of the acid is equal to 8 weight of the acid upon molar mass of the acid. So 8.0 upon 80, that will be equal to 0.1 mole. Moles of the water will be equal to weight of the water 487. We calculate the mass of the solvent. So 487 is the, you can see here mass of the solvent. So 487 is the mass of the water upon molar mass of the water H2O. The molar mass is 18, that will be getting 27.06 mole. Now we will be calculating the moles of the acid. X of the acid will be equal to moles of the acid upon moles of the acid plus moles of the water, that will be 0.1 upon 0.1 plus 0.1 upon 0.1 plus 27.6, we will be getting 3.68 into 10 raised to the power minus 3. This is a unitless quantity because everything is in mole, so mole will get cancelled out. And mole fraction is a unitless quantity. So 3.68 into 10 to the power minus 3. In the same way, if we have been asked calculate the mole of the water, so mole of the water upon, we will put mole of the water upon mole of the acid plus mole of the water, we will getting again the next value. So this is how we can calculate the mole fraction, right? Now one of the most important question that you will be getting this in this chapter, that is you will be given question like this: a sample of HCl contains 30% of HCl by mass and has density. You will be getting density, and the strength of the solution is defined in percentage. So density 1.0 gram centimeter cube. Calculate its molarity and molality. Remember, this type of question has been frequently asked in competitions also, right? So how you can calculate this? See, very easy. Mass of 1000 centimeter cube of 1 liter volume of the solution, that will equal to 1000, that is volume into density. Mass is equal to volume into density. Simple. Mass is equal to volume into density, that is 1200 gram. Now mass of HCl in 1 liter solution. So how you can calculate the mass of HCl? So total mass of the solution is 1200 gram, and in this 30% is HCl. So 30% of 1200, 30% of 1200, 30% of 1200, that will equal to 30 into 1200 upon 100, that will equal to 360 gram. So what is the weight of HCl? 360 gram. 360 gram is the weight of the HCl, right? 360 gram is the weight of the HCl. Now molar mass of HCl, hydrogen molar weight 1 and chlorine 35.5, that will equal to 36.5. So the value is 36.5 gram mole inverse. Now molarity is equal to 360 upon, molarity is equal to weight of the solute upon molar mass of the solute, that will equal to 360 upon 36.5 in 9.86 mole. We are not multiplying it by 1000 because already this we have solved this. The volume is in 1000 or 1 liter. Now for molarity, again for molality you have to calculate the mass of the solvent in 1 liter solution. So mass of the solvent is equal to mass of the solution. Total mass of the solution is 1200 gram and mass of the solute is 360 gram. So when you will subtract this, you will getting 840 gram. Now molality will be equal to 9.86 upon 840 into 1000, that will equal to 11.74 mole kilogram inverse. So this is the easiest way to calculate the this molarity and molality, and you will be getting this types of question in this format in competitions. Now I will teach you one of simple method to calculate molarity when problems of these types are given. So you can see the problem. A sample of HCl contains strength is 30%, strength is 30%, and density is 1.20 gram centimeter cube, and you have to calculate the molarity and molarity. So molarity will be equal to 10 ds upon molar mass, 10 ds upon molar mass. So 10 into 1.20 into strength is 30 upon molar mass is 36.5. You will solve this, you will be again getting the answer 9.86 gram liter inverse. You will again getting the same thing, or molarity, not gram liter inverse, this will be molar, right? So this is keep practicing all these problems from NCERT book, from any solved. First of all, try to solve the numericals which are given, in which solutions are provided. Don't jump directly on IT questions or some difficult questions, because you will not be able to solve all these things without clearing your concept, and you will get confused. So I advise you, first of all, solve the numericals whose solutions are given, which are easy. Don't directly jump on IIT or some competitive questions, right? And we will be discussing another part in our next lecture. Till then, don't forget to subscribe my channel and press the bell icon. Thank you.